Hi, and welcome to the second Vray class, which is about Vray Material, and we will have two classes for Vray Materials. The first class we will talk about Vraymtl or Vray Material, the standard and the first Vray Material. And also we will talk about Vray Material online source. The reason that we start with the Vray Material is that this is the most important and use it in the arc. So I prefer to start with this material, and we will focus on this material and will discuss in detail. And the second topic is the Vray Material online source. What's that? It's same as some website that you can download the free materials for Vray. Actually, I just know one, which is a Vraymterial.de, and it's almost the biggest one. There are some others, but this is the biggest one. But of course we are not going to put this as our course, and as I just introduced, the site should be enough. What we will focus is how to use these materials. The main problem that the users have is that after they download these materials and they apply to their own scene, it is not similar to what they have seen in the preview picture, or even when they find a material from the other scene, they save it from there and want to use it in their own scene. It's not same as what they saw in other scenes. So we will learn how to match the materials from other scene or from the online sources. So let us start with the Vray material. I have a scene, very simple scene, and I already applied the Vray. I don't talk so basics. We should go to the assign renderer and choose the Vray, which I already chose, and my setting is very simple. I am using the GI irradiance map and the light catch with the low settings, and also I am using the frame buffer, and nothing changed here. I am using the Vray HDR map for the both GI environment and refraction and reflection environment. Now in our scene we are using the 3D Max standard material, the green color and the ground. The question is that why we need to use the Vray material, and if the standard material, standard 3D Max materials working in the also Vray, yes, the 3D Max standard materials also work in the Vray render engine. But why we need to use the Vray materials? For two main reasons. One is that some of the 3D Max features cannot be supported in the Vray render engine, such as the ray traced map, ray trace shading, and also using the Vray material is faster. Now I have this scene and set to the 3D Max standard materials. I render it, and see the result is 4 second and 4.8. Now I want to apply the Vray material, so another sample slot, hit the standard button, and because we already applied the render engine, Vray render engine, so we can see the Vray materials and actually the Vray materials and Vray maps. If we don't change it to Vray render engine from the render panels, render setup panels, it will not show Vray shaders and maps. So I will choose the Vray material, the first Vray material, and I give it the green color, same as what I had in the standard. Nothing else will change. And this also just a Vray material, no need anything change. And this I apply first, render it again. The passes is almost in the same time, but the final result is more natural, better, and the time reduce it 3.8 seconds. So it is the reason that why we need to use the Vray material. So don't think if the object doesn't have any special features such as a reflection or refraction, so don't need to use the Vray material. And don't think this is just a 1 second changes. In a complex scene, of course, it is much more. Imagine if your scene is rendering with 48 minutes, then with the Vray material, it should reduce to 38 minutes, almost 10 minutes saving time. Well, but if already your scene, you apply all your object, 3D Max standard materials, same as now, I just changed them back. You can right click and you have the Vray scene converter. When you click on this, it will ask you if you want to convert, and you will convert it. Actually, also warning about ray tracing, shadows, and rest. It will convert your materials to the Vray. Now that standard material changed to the Vray material. With the, as much as it can, it try to use the same parameters and same values. Also, you can notice that other slots from the standard change it to the Vray material. Okay, just let's apply our material. And well, the Vray material has the several rollouts: basic parameters, BRDF, options, map, reflect interpolation, and refract interpolation, and we will talk about all of them in this lesson, in this class. The first one and the most important one is the basic parameters. In basic parameters, we have 4 groups: diffuse, refraction, reflection, refraction, and translucency. The first one is diffuse, and it will you can actually choose your color from here. You probably know this color selector well. Just as a tip, I say you that the value, because you can set according to RGB or hue, saturation, and value. The value here can move those other parameters as well. I just back all, so it will move the red, green, and blue as well. If for example you want to have a gray color of the 50, you no need to type 50 in 3 fields. You just can type 50 in the value and hit the enter. Sorry, all be 0, and just the value you can change to the 50, and all RGB will change to 50 as well. Here, if you have for example 10, 20, and 30, the value will show the highest. For example, if it be the 50, the value will show the 50. And if be here 20, if I double the value, double 60, all these 3 will be doubled. 10 will be to 20, 20 will be to 40, and 30 will be to 60. So this is just some mathematical relationship between these parameters. Not very important, but sometimes it can be useful and a more expert look if you just change one value. Okay, and actually we're working on this material. Besides this, you can apply the texture to your diffuse and use the texture, not the color. When you hit the this texture icon right to the color swatch of the diffuse channel, it will open material and map browser, and you can same as what you did before in the with the 3D Max materials. Just in the standard maps, double click on the bitmap and you can choose your map. You have learned this part before, and the rest I just clear it. And you can use also the procedural maps as well. But what is actually diffuse? How the diffuse is working? All of these things, diffuse and reflection, are come from the BRDF, bidirectional reflectance distribution function. And one is the diffuse reflection. When the light rays shoot and hit a surface, it will bounce to different angles and in a hemisphere shape, is such as a stone, a rough stone, impure stone, or any object that is not smooth. It will, when the light hit, it will reflect the light in a different direction, so you cannot see any reflection. So it will cause, and it will call diffuse reflection totally, and you just see the color. Well, the next part is the reflection. We have the reflection color, which is from the black to the white. White means 100 reflection or mirror, or also can call a specular, and black means no reflection. The tones between the black and white is just different intensity and different strength of the reflection. I put it to white color, and if you want to see in the preview, you need to apply background. Now you can see it look like the mirror. You already applied to the teapot, and just hit the render. Well, it just look like the chrome and the metal. So I reduce it without any reflection, and it is showing to me the diffuse color. I reduce this and look at the render time, 4.0. Sorry, 4.1. I change the value to 100. Well, let's have a gray color, actually is better, and render it again. Render time increased to 5 seconds, and you can see the reflection. Change it to 200. Render it. Render time again will be increased 5.1 and more reflection. Change it to 255 is actually the per white, but I want it be 2.254, a bit, just 1% have a reflection. Sorry, 1% is just to be 255. And again, render time increased to 5.6 and almost mirror, almost a chrome. Now I change it to the highest, absolute white, and render. Now the render time decrease. So keep in mind, with increasing the reflection, the rendering time will be increased too. But the poor white and the black are actually the same render time. The effect, the result is different, but the render time is similar. So it is one of the things that you should know for your rendering time. Don't think that, for example, if you put it 2.3 or 2.253 or 254 is same as the white color. The result are almost same, but noticeable rendering time will be changed. And of course we just have one teapot here. If be the complexing, will be very different. Okay, so this is the white color and this is the reflection. Also in the reflection you can use the map. For example, I use the checker now, and one be black means doesn't have any reflection. I change it to the little bit gray and render it. Now in the some part we will see the almost mirror, and some part diffuse channel. I remove it, remove the map, and let's talk about the specular reflection. A specular reflection is same as what we just saw, 100% reflection, and the mirror look like the rays come and with the same angle will be left to the eyes. So it is same as the mirror and nothing will be changed. Everything is similar, is absolute mirror. So this is the second BRDF part, which is a specular reflection. By the way, I think I forgot to say to talk about the BRDF is some kind of the let's actually talk about this when I am speaking about the Fresnel little bit. Well, then we have the reflection closeness. When it is set to 1, is doesn't have any, will not show any effect. But as soon as you will change it to reduce it below to 1, it will start to be blurry. It is going to be blurry. Let's actually, we can see it here also. It's okay. Or maybe I just create a wall. And let's give this give this to this one and this one just a diffuse green. Let's render. Well, it is, you can see the reflection and you can see the blurry effect. Actually no need this, I think the teapot will show it better. and we can also reduce. As much as you reduce it, you will see a point here which call highlight, or the real name is high up light. This is automatically will be creating. When you reduce the glossiness, it will be bigger and wider. It is losing the energy and it will getting the wider. So for example, right now I will render, and rendering time significantly will be increased. So you can see the blurry effect and the reflection. But I cannot see this point, right? I cannot see this point, which is the highlight actually. This is not the highlight, this is reflection of the environment. Where I can see this highlight is where there is a light source. I use a standard light Omni and apply it. Actually this is also the some kind of the highlight, but come from the environment, not the light. I put the light here and now I will render it. I stop the rendering and don't waste time. And now we can see the highlight effect. It is working physically correct, so when I reduce the glossiness, it will wider the highlight. The quality of displays is depend to the subdivision field. We will increase it, the quality will be higher, and we will decrease it, the quality will be lower. It doesn't mean that you must always use the high quality. In our project, when we are working in the interior, you will find that there are some times that you even need to use a very low value, such as a 4, for creating the realistic material. I will show you in our project, so just keep it for now. In this part, I just try to introduce parameters and the ability, and how they will work in the real project I will show you in our project. Well, so this is the reflection glossiness. Glossy reflection is like this, that the light hit the surface, but almost in the same direction but different angles, a bit different, and this will cause a blurry effect. So that is why we are looking at the object and it looks blurry. The light hit and in the same direction but different angle. So this is how we can describe glossiness. But we have the highlight glossiness also here, which is locked to the glossiness. In fact, this is locked and it is physically correct. If we unlock it, we can change the highlight glossiness manually and create what we want. Even we can keep it high, reflection glossiness be high 1, and just reduce the highlight glossiness. It is not physically correct, but in many situations we can use them. Again, in our real project we will know when. And let's continue talking about the highlight. In the 3D Max standard material, we call it a specular level highlight, actually is the wrong name. Sorry, specular is the wrong name and the highlight is the right name. So a specular highlight is the fake one in the 3D Max, a standard material, and you can create it without having any reflection, same as what we did just now for this material. There are some times that we can use the 3D Max standard materials as well to reduce time also. For example, here I just applied the Vraymtl effect. I will talk about Vraymtl a bit later. And this one I reduce the glossiness. Well, and the same color I will apply to diffuse in here. Let's create almost the same shape. Okay, and create the two teapots. One will have the Vray material and another one will have the standard material, and let the render them first side by side to compare. There are some situation your object is far to the camera, your object is small, and you really don't care it reflects the environment. We just want it has a small specular. Look at this. This is the standard material. It has this specular, but it doesn't reflect the environment. But this one is reflecting the environment also, but not much difference for the small objects, right? So what is the difference? Almost this one, the Vray was better, of course. And now I will apply both the Vray. I want to check the rendering time. Now both using the Vray material, and the render time is 12 seconds, almost 13 seconds. Now I will apply the standard 3D Max material and render again. Five seconds, almost 6 seconds. So become half. The rendering time become half and not much difference. So this is one way that you can use the standard material as well. But still there are some tricks that you can use Vray material and also reduce the time. Well, here I will use let's just change this one, and I just use the highlight. I need to have a reflection, and also I can change this or not. Then I need to go, because now it is reflecting 100%, reflection is high. I can go to the options. This option is by default is selected. I can deselect this option and it will not reflect any object. It will not reflect this material. So this reflection for this material will be ignored. But it already has its highlight. So if I just give this one the left Vray and the right without reflection and render, Well, almost the same, just same as the standard one. It doesn't reflect the environment. And if I just come here and let's apply, okay, I just did the same to both. Okay, now render it again. Well, you can see the reflection of the environment in this material, and this one doesn't have, just has a highlight. And about the rendering time, let's check it. Both of them have the same Vray material without having reflection, but with glossy, with highlight, and the rendering time is 6, almost same as the standard material. So actually in many cases this is also even faster than the standard 3D Max materials. So this is some of the tips that you should keep in mind when your object is far or not very important, is small. You don't need always follow the natural rules and the physics rules. You can use the tricks to reduce your rendering time. Well, and you can use the maps for both reflection glossiness and highlight glossiness. Before we move to the Vray reflection, I should say that the Vray material follow the physics rules of the energy conservation or energy preservation. Also here you can see, which we will talk later. And so we don't need to care many things. It means, for example, there is always 100%. I prefer to type it to make sure you understand. Always there is 100%. For example, if the reflection is equal to 50% or let's say 60%, diffuse cannot be more than, for example 41%, because the sum of these two must be 100%. So if I increase, so it should be just 40%. So if I increase the reflection, diffuse will be decreased. And keep in mind that the reflection is number one, then refraction, and the last is the diffuse channel. It means if the refraction be 100%, if it be 100%, we cannot see any diffuse color, because the refraction is higher and in the top of the diffuse channel. So when we even the diffuse be 100%, when we increase the refraction it will be reduced, and reflection is in the highest place. It means if reflection be 100%, the refraction and the diffuse effect will be ignored. So now also I wanted to say that sometimes we can use the color instead of the reflection. Now that we are using the gray color, you can see that actually I just make it 100%. As soon as I decrease the reflection, the green color, which is diffuse, is applying. In the 3D Max standard material, it is we doesn't have this rule, so we should keep in mind and don't make something over or less. Well, or same as refraction. Actually, let's make it black, and as soon as I decrease the refraction, the diffuse is removing, and as soon as I come to the reflection and decrease it, actually increase it, sorry, the refraction will be removed and ignored actually. Okay, and this is the rules of the energy conservation. We will talk about this also a bit later, just the parameters. Well, and also for the reflection we can use the, sorry, I just use the colors, and when we are using the colors, this reflection color will be mixed with this diffuse channel. So remove one of them is enough. So we'll be create something new, actually some new color. Well, now back to the Fresnel effect. What is the Fresnel reflection? Fresnel is the name of this French scientist, and the Fresnel is his rule's name, his law name. You can search about Fresnel in the internet and find his rules. But totally, if I want to say, the Fresnel effect is for dielectric materials such as plastic, glass, and also water. Water is not kind of the dielectric, but the transparent object. We can call dielectric or transparent object. So we use this effect when we create some dielectric non-metal objects. So, for example, what the Fresnel effect say is that the reflection will be changed according to the angles. I apply it and render it. It said that the reflection at the 0 angle is less than reflection at the 90-degree angles. You can see here is 0 degree. It means it's in front of your eyes. It's 0 degree. You don't have any angle with this, with here. But here it is turning and angle is become wider. Here is 90, and in the 90 angle it has the highest reflection. Or when you are looking at the shop, let's give a better another example. Actually, I apply this to the ground, and let's remove this ball and change the color to the white color, and create a teapot here. Okay, I am from the top. For example, this is the shop. This is the glass of the shop. It doesn't matter, we are just using now reflection, but for the refraction is the same. When I'm looking from the front, almost look how much it reflects my object, and when I reduce it, let's make the duplicated, and when it is reducing the angle, you can see more reflection. So the BRDF, actually our scene has too much light. I think I forgot to remove these lights, sorry. Let's remove this and render it again. It creates so much light. Okay, you can see as much as you reduce your angle, I duplicate this one and again move to here. As much as you reduce the angle, you can see more reflection. Now you can see more reflection of this object. So it is actually the Fresnel rules, and I think all of you already know this, so I don't describe much. You can search in the Google about the Fresnel law more. So this is what we use for the dielectric materials, and it is according to what? It is according to IOR, index of the refraction, which we will talk more about when we are speaking about this introducing refraction. For example, for the glass, the IOR is 1.5 or to 1.56, or water is 1.33. It has a table that I need to give you a table, and you can even search it. And the one IOR of 1 is actually the vacuum or the air. For example, if I just change the refraction and actually let's give the ground and refraction to the 0 and the 1 and no reflection at all, give it to this teapot, and when you render it, except this part which is actually it has a black background, the rest you cannot see because there is no any bending the light, which I will talk about this later. I just wanted to show you the one, it means no bending the light, but bending the light and the index of refraction is related to the refraction. Why we need to care about this in here, reflection? Well, this is what will be happen in the dielectric materials. When the light hit the surface, some rays could go inside one layer below of the material and can bounce off there, and when they exit they will carry out the color of this object, and some of them will just reflect from the surface, will back from the surface. They are actually the reflection of the environment. So some of them will carry out the color and some of them will be carry out the reflection. That's why we already have the bending of the light. The light can pass through the layer, the first layer of the object. That's why we need to have the index of refraction. But it is what will be happening in the metal. The light hit the surface and cannot go inside at all, so just back. That's why you can 100% see the reflection. And this is how the Fresnel reflection will work, and we will talk about this also in our project much more. There is a one L button here, L button, and which is if you deactivate, it will let you to have another Fresnel object, Fresnel IOR. You will not use this IOR anymore, and you will have your own IOR, index of refraction. According to the physics, this is correct that we should just use the refraction IOR, but sometimes we need to use the we need to unlock it and use our own IOR for reflection. There are some reasons, and I will tell you right now. First, let's show you the Fresnel chart, and because in the Vray it doesn't have any visual part, so I will use the mental material, just because I want to show you this IOR, because here it will show you like this the graph. It has a visual graph, and when I am using the Fresnel reflection, for example 1.5, you can see the reflectivity from the zero angle, which is in the front of the face, has very small reflection, and when it go to the 90 degree, the reflection is so high. So this is how the Fresnel effect is working. For example, if I change it to 1, almost 0. If I 1.1, you can see how it is changing to 1.8, 2.5, and this is according with this mental arc and design material. You can see it. When you are not using the IOR, in fact you are using 100%. Sorry, when you are not using the Fresnel effect, in fact you are using 100% reflectivity for all angles. But there are some times that you need to use the IOR for the metal materials also, with the high numbers from 25 to 14. Look at the Fresnel effect when the value is 25, almost very near to the top, and the direction is inverse from the when it is 2.5, for example, or 14. There are sometimes that you need to use this way of the Fresnel. That's why it lets you select it separately. And I just change the color to the green again. I am using the Fresnel effect, unlock it, and reflection actually should be 100%, and the refraction I back it to black. That is why when I am not using the Fresnel effect, the reflection is so high. But as soon as I apply the Fresnel effect, you can see lots of color, because 1.5 is not so close to 100%, or the poor white color in here. It is same as we have the very dark gray here, and going middle gray, and finally will be the white color here. That is why with the Fresnel effect it will change like this. Okay, I change it to 25 and change this to the yellow color, such as a gold color, and render it. Well, almost some kind of the gold, but it's not real gold, because I just wanted to say that it will flowing the diffuse color. It will take some of the diffuse color, because as you can see here, mm, 25, it is not 100%, maybe it's just 90% reflection, so 10% could be diffuse. But I can also apply the same color to the reflection to create some kind of the gold material. However, this will again create this color mixing, so maybe the diffuse just be black color, and then we can hit the render to create some kind of the gold material, because some metals also have the color, their own color, such as gold or silver. I will show you when we need to use our own Fresnel in the real example. Another side of this, one of the another example that we will see in our project is that, for example, there is a mirror, there is a glass, windows glass, but because our camera angle, we cannot see any reflection on the glass, and it looks like there is not any glass, there is not any window. But we cannot change the IOR because the light is bending, and if we change the IOR, the outside scene or inside will look unnatural. So we can come here and, for example, change it to 2 and see some reflection from the inside of the room. These are some tricks that we will talk about, all of them. This video I will stop and I will continue because it already becomes so long. I will continue the rest parameters in the next video.